So in the next of these introduction to chemistry videos, we're going to review your understanding of acids and bases and salts, and probably extend it a little bit from GCSE. So the first thing we need to do is consider what we understand by the word acid. And this is probably a little bit more than what you said at GCSE. An acid at A-level is a substance that donates H plus ions. And sometimes in A-level chemistry you'll hear people refer to those as protons. So a substance that donates protons might be another way that we would describe an acid. And you might think, well, protons are inside the nucleus, how can H plus ions be protons? But if you just take a minute to consider what a H plus ion is, so let's just consider hydrogen in the periodic table. Looks like this in the periodic table. And what that tells us is that there is one proton and therefore one electron, because it's a neutral atom, but no neutrons, because one take away one is nothing, no neutrons in an element of hydrogen. So one atom, of hydrogen, not the element. We've got one proton and one electron. So in the nucleus there's one proton, there's no neutrons, and around the nucleus in shells there's one electron. So if we consider the H plus ion, well, it still has the one proton in the nucleus, but it's lost its electron. So it now has no electrons and no neutrons, and now we can maybe understand why a chemist might call a H plus ion just a proton, because that's all it is. It's just one proton and no electrons and no neutrons. So we might refer to an acid as a proton donor or as a substance that donates H plus ions. So we're going to remind ourselves quickly of the formulas of those common acids. So we've got HCl, which we should all know, and H2SO4. And then remember that nitric was HNO3. Now ethanoic you might have come across at GCSE, it's one of the organic acids. CH3, COOH. S in organic chemistry means two carbons, and there's two carbons in there, and it's a carboxylic acid. It's got this two group, ethanoic acid. So these are some of our common acids. And then we've got a base. So what is a base? A base is the thing that accepts the H plus ion, so it might be referred to as a proton acceptor. From the acid it's going to accept the protons. So if we look at this example here, we've got an OH minus acting as a base. This is a hydroxide ion acting as a base because it's going to accept a proton to form water. The hydroxide ion is the base. So OH minus is a base. It accepts, which is the definition, H plus. So if we look at this one, and I show you that if I put NH3 and H plus together, I get NH4 plus. Just remind ourselves, this was called ammonia. And this is called ammonium. So what's the base? Who accepts the proton? NH3, ammonia, is a base. It accepts protons, H plus ions. So what's the difference then between a base and an alkali? Well, the only difference is an alkali is a base, it's like a subset of a base, and it's one that releases hydroxide ions when it's in solution. So some of those are kind of obvious from the name. Does sodium hydroxide, when it goes into a beaker, does it separate into sodium ions and hydroxide ions? It's got hydroxide ions in it, so it's an alkali. Potassium hydroxide has got potassium ions and hydroxide ions, it's an alkali. So then aqueous ammonia, how can that be when ammonia's formula was NH3? How can that have hydroxide ions? Well, it's all to do with this word aqueous. What does that mean? That means with water. And when ammonia is in water, what happens is it forms ammonium hydroxide. And so aqueous ammonia is actually NH4OH, and we can see the hydroxide ions. In an exam, you would be allowed to just write NH3AQ as aqueous ammonia, because that's the formula of ammonia, and AQ means aqueous. Or you could write NH4OH, but most people would tend to just write this as the formula of ammonia. Skip past alkyl protons. Right, so then salts. This is a definition that you probably didn't use at GCSE, or if you did, you said it's just when acids and alkalis react. You can't use that at A level. It's probably one of the most useful definitions to get equations right. It's formed when the hydrogen ions of an acid are replaced by metal or ammonium ions. So we're going to take the hydrogen ions and swap them for a metal or an ammonium ion. So if I want to make something chloride, like sodium chloride or potassium chloride or magnesium chloride, I need to think which acid contains chloride ions. And so I'll be thinking to myself, which acid? And we can say to ourselves, well, that's hydrochloric acid. Which is HCl. And if I swap the H in HCl for a metal, I could get NaCl, KCl. If I swap it for magnesium, I do need to remember that magnesium 2+, so to balance it I'll need 2 chloride ions, MgCl2, but I'm swapping the H's for metals. So these salts are made from that hydrochloric acid. Sulfates are made from sulfuric acid, H2SO4. So we've got some examples of sulfates. The one that you might have made at school, copper 2 sulfate. It's made from sulfuric acid, where we swapped the hydrogens in sulfuric acid for the metal copper. Now there's 2 H's because each one of them is 1+, but there's only 1 Cu because it's 2+. Nitrates are formed from nitric acid, which is HNO3. So we could be looking at something like NaNO3, sodium nitrate, or if we had to do calcium, this is group 2, we'd need 2 nitrates. And phosphates are formed from phosphoric acid, H3PO4, where we're replacing the hydrogens of phosphoric acid, the hydrogen ions, with metals. So if we replace it with aluminium, which is 3+, all 3 hydrogens replaced by 1 aluminium, 3 1+s is the same as a 3+. But if we had to come up with something like calcium phosphate, that would be a bit trickier because calcium's in group 2. So we would need 3 calciums to balance 2 phosphate ions. The phosphate ion must be a 3- ion if it's got 3 hydrogens in the phosphoric acid. So what do we need to do here? We need to go backwards, work backwards to the formula of the acid. So what I would do, some of these you think, oh, they're too easy for this method, but it's better to know the method and apply it than to not know it. MgSO4, what's it made from? It's made from Mg2+ and SO4 2-. That's magnesium sulfate. So what acid contains SO4? How many H's to balance 2-? 2. 2 H pluses to balance SO4 2-. Calcium phosphate is made from calcium ions and phosphate ions. There must be 3 of these to balance 2 phosphates, so the acid would be H3PO4. Ammonium nitrate. So we've replaced the hydrogen with a metal or ammonium, so we're getting rid of the ammonium ion, which is this bit, this bit here, we're getting rid of that and we're replacing it with a hydrogen ion. Hydrogen's got 1+ charge, so we just replace it, it's HNO3. Now this is where, if you were just knowing the formulas of some acids, you would fall apart, because KNO2 is made from K, which is in group 1, so 1+. And I've never heard of this NO2 thing before, but given that it was 1K with 1 NO2, then the charge on it must be 1-, because 1K plus would need 1 NO2- to balance it. So then I need to think of what goes with the NO2 to make it an acid, and it's a H, and H has the 1 plus charge, so how many H's would you need for an NO2? 1 minus, just need 1, HNO2. These two here are both called nitric acid, but one of them is called nitric 5 and one of them is called nitric 3. We will learn about that later in the course, but they are both types of nitric acid. So magnesium ions are Mg2+, which means this SO3 that I've not seen before must be 2- to balance the 2+, and therefore the acid must have 2 hydrogens in it to balance out the 2 minuses. This is made from CH3COO, and I'm not sure about that, but I know that Na is Na+, so this must be a minus. I'm going to put a hydrogen ion back onto that, and that's going to be ethanoic acid. So what we're going to do in the last little section of this video is remind ourselves of what happens when acids react. So acids can react with alkalis or bases to make salts and water, with metals to make salt and hydrogen, and with carbonates or hydrogen carbonates to make salt and water and carbon dioxide. What I'm going to just do now, and this will be really useful later in the course, I'm going to just highlight this one. The other 4, I'll highlight them in a different colour. These 4 would all count as neutralisations, because they make water. So these are your normal acid reactions that are neutralisations. But that blue one, it doesn't make water, so it's technically not a neutralisation. This is actually a redox reaction. So it is a bit different to the others, but it is still a reaction of acids, which is why we're going to cover it in this section. So first of all, we're going to look at these, decide which one of the types, and then you're going to use your rules for writing formulas and balancing equations and coming up with formulas of salts to have a go. So we'll go through one together. First thing I'm going to do is decide which type. Nitric acid is an acid. Easy. Sodium hydroxide. If I go back to my definitions, I know that hydroxides are alkalis. So this is acid plus alkali makes salt plus water. What would be the salt of nitric acid? It's going to be a nitrate, where I've replaced the hydrogen with the metal, so it's going to be sodium nitrate plus water. So what I want you to do now is pause the video, put in all the formulas of those things using our earlier work on formulae, and balance the equation, again using the early work on balancing equations. Okay, so we should have got that. Balances without any numbers. So there we go. So sodium nitrate plus water. So let's have a look at our second example. We've got hydrochloric acid plus magnesium oxide. Now oxides are bases. So this is acid plus base makes salt plus water. The salt of hydrochloric acid is chlorides, and we'll replace the hydrogen with the metal, so it's going to be magnesium chloride plus water. So again, pause the video and have a go at balancing the equation. So I've written the formulas in, but I haven't balanced it, just to remind you about that Macho rule. So 1 mg, 1 mg. I've balanced the metals. Now I'm going to balance the thing that isn't carbon, hydrogen or oxygen, so the Cl, 2 Cls. I'm going to put 2 Cls in front of the acid, 2 in front of the acid, and then 2 H's, 2 H's, 2 O's, no, 1 O even, 1 O. So that's balancing the equation. See if you can finish the page. See if you can identify the type, put the products, and write the formulas, and balance the equations. So there you go. I'll just leave that on for a minute so you can check through your answers. So we've got each of the different types there. We started off with acid plus alkali, then we went to acid plus base, acid plus metal, acid plus carbonate, and then acid plus hydrogen carbonate. And we balanced every single one of them, making the salt, so replacing the hydrogens of the acid with the metal ion, and water and carbon dioxide. In these ones, and in the bottom ones we had water and carbon dioxide, top ones we had hydrogen or water. So just check that you can write and balance equations for acid reactions. It's very, very common at A-level chemistry.